All right, so hi everyone. I'm really excited to be speaking with you today. I'd like to begin by acknowledging the traditional territories of the people of the Treaty 7 region in southern Alberta. The city of Calgary is also home to the Métis Nation of Alberta, Districts 5 and 6. So I'm located in Calgary right now. So we've already gone over a little bit about me, and then going to this project. It began as my master's thesis, and now it's a paper under publication review. So I wanted my research to address an issue that really affects us all. And with wildfire smoke becoming a yearly reality, I decided to focus my work on understanding its impacts. I also want to acknowledge the fires that are currently happening in Eastern Canada and on Vancouver Island and wherever else I haven't seen in the news. I'm fortunate that there's no smoke here right now, but I know that there is elsewhere. So to give some background, which I'm sure you're all aware of, the fire regime in Canada and in Western Canada, where we're all located, has been worsening, especially over the last 10 years. So the length of the fire season is increasing. For example, the Canadian fire season now starts on average 1 week earlier and ends 1 week later than usual. So in the pictures above, you can see devastating fires in Kelowna in 2023 and the Jasper fire as well. So I was just in Jasper recently, and it was shocking to see how much burnt compared to when I was previously there. I think around 1/3 of the town and an estimated $1.2 billion in damages. So other disasters that are quick to come to mind are Lytton, which I'm sure that Patrick will be detailing later, as well as Fort McMurray. And then so fires in general becoming more severe with the hotter and drier weather that we're experiencing. And the area burned in Canada is increasing almost every year. So in 2023, 4% of Canada's forested area burned. And now fires are also increasingly displaying extreme behavior. So creating their own weather, creating their own lightning, and then zombie fires that continue to burn throughout the winter. So all of these increasingly extreme behaviors lead to more smoke experienced by Canadians, a noticeable difference even from 10 years ago. So I found this chart on the City of Calgary website. You can see the number of smoke hours experienced by Calgarians has gone up dramatically in the last 10 years. So in 2023, Calgarians experienced over 500 hours of smoke. So even though this chart is just for Calgary, I'm sure that others are experiencing this in your homes as well. And smoke is not only a quality of life and healthcare issue, but also a potential indirect risk to energy infrastructure. So smoke can travel extremely long distances depending on wind and weather patterns. So in these 2018 satellite images, you can see smoke from active fires in northern BC being transported to Alberta. And smoke can actually travel all the way around the globe. So when I was living in Portugal in 2023, wildfire smoke from the Canadian fires affected air quality even there. So smoke impacts solar energy because it scatters and absorbs sunlight, reducing the radiation that solar panels rely on most. So the scattered light is softer and less intense, meaning less energy can be generated. So the two photos on the bottom show how wildfire smoke visibly changes the sky and reduces solar supply. So not only is it annoying for life, but it also is a risk to our power supply. So I chose Alberta as a study location. I know most of you are located in BC, but it's because it's where I grew up and where I feel a connection to, but also more importantly, because it has some of the highest solar potential in Canada, as we can see on the map on the right. It also accounts for a very large share of the country's installed solar capacity and much of Canada's recent renewable energy growth. So I think it was 92% in 2023. So in general, the goal of my research was to understand and quantify how wildfire smoke affects solar generation in the Canadian context. So there's lots of other studies that look into this in California or in Australia or in other regions affected by wildfires. There's also some studies that look into other forms of air pollution, so anthropogenic pollution in Asia, but no similar analysis has been conducted in Canada, although my colleagues at the University of Calgary are beginning some work on this. So I really wanted to establish a baseline economic estimate of the PV potential loss due to smoke, and in general, just explore less obvious externalities of smoke exposure. And lastly, I wanted to do a multi-year study. So most studies now are just a singular event or over 1 year. So I wanted to look at things more long-term. So the first challenge I encountered in doing this research is that wildfire smoke is very difficult to measure. Conditions can change very rapidly with shifting wind and weather, and different measurement variables have advantages and disadvantages. So for this study, my co-author and I used fine particulate matter known as PM2.5. PM2.5 is usually used for monitoring of health outcomes. So most stations are located where people live and not in the remote areas where a lot of solar farms are built. So because of this issue, I had to exclude several large solar farms from my analysis just because they are too far for monitoring infrastructure. And in other locations, PM2.5 can be influenced by other forms of pollution. So car exhaust, et cetera. But in Alberta, it's generally a pretty reliable indicator. And you can see in this chart that PM2.5 levels really only go into the danger zone within the fire season and from wildfires. So the key takeaway that I want to give to the non-technical audience is that we need a more robust and geographically distributed smoke monitoring network. So putting this maybe in non-urban locations, and that we should start looking into combining multiple measurement methods to truly capture the impacts of wildfire smoke. So for time's sake, I'm going to skip over most of my study design and detailed methodology. I'm happy to discuss it in the Q&A, but my key points is that the study spans over 6 years. I used 28 actual solar sites in Alberta, and to determine my results, I applied machine learning techniques. So in terms of my results, highly impacted sites saw reductions of 6.4% with a site-wide average of 3.9% in severe smoky periods. And this led to an estimated 4.5 million in lost solar potential. And basically the more severe the smoke, the higher the losses. And these numbers are fairly comparable with studies in other geographic areas, although slightly smaller. The studies with larger results generally used higher thresholds for the level of smoke they analyzed, or they only looked at a singular event over 1 week or 1 or 2 weeks. So in the Western US, they saw 8.3% losses. In Australia, 7% losses. And in a real life case study in California, there was actual production losses throughout the grid of 13% during the 2020 wildfires there. So what are the implications here? A 3 to 6% reduction in solar power might not sound significant at first glance, but if that shortfall is unexpected, it can create cascading challenges for the power grid. So my study didn't focus on forecasting. I instead wanted to establish a historical baseline of smoke-related impacts. But accurate forecasting and understanding the effects of smoke on solar is critical for grid stability, efficient operations, and the successful integration of renewables in general. So for example, during the 2020 California wildfires, solar output dropped by 13%, but forecasting models overestimated production by more than 50%. This was because most forecasting models don't incorporate aerosol data, so they fail to account for the effect of smoke on sunlight and solar production. So this inaccurate forecast can force grid operators to increase reserve requirements and activate expensive, often carbon-intensive backup generation. In the 2020 California wildfires, reserve requirements increased by 53%. So over the long term, all of these inaccuracies can create uncertainty for renewable energy investments, especially in smoke-prone regions, making it hard to plan and finance new projects. And now I'm just going to go into some charts of my results. So this chart shows the seasonal power of solar output, which peaks in the solar months. The y-axis shows the daily sum of power produced, and the size of the bubbles of this is the severity of the smoke that day. So notice that high smoke days never appear on the upper end of the production spectrum, showing a strong correlation between smoke and reduced generation. And I also wanted to note that other research suggests that the timing of smoke events, both the time of year and the time of day, can influence generation losses. But this area is a little bit underexplored, so hopefully there will be more research on that coming out soon. And here I broke down the losses by year. So you can see that the largest losses occurred during the record-breaking wildfire years, so 2021, 2023, and 2018. And I divided the bars into moderate and severe smoke proportions. So severe smoke, where PM 2.5 was higher than 27, was responsible for most of the losses. And this matches findings from other research where solar output declines the most under concentrated near source smoke, while long range transported smoke has smaller impacts. So a reminder that the location of a solar installation matters. Regions close to wildfire activity face greater risks to solar generation. Okay, and here I just wanted to demonstrate the relationship between the concentration of smoke and solar generation losses. So you can see that as the level of smoke rises, so do the losses, I think tapping out around 9%. And this is comparable with findings in other geographic regions. And here I just showed losses at a singular site in May. So this is over 1 week in May 2023. And the bars show the amount of generation that was lost due to smoke, with the line showing smoke levels. So the periods without bars take place during the nighttime. And you can see whenever there's a spike in smoke levels, there's also a corresponding spike in power generation or loss of power generation. So this shows the operational challenges of how quickly smoke conditions can change and affect solar output. And lastly, going into some discussion about my research, one limitation is that I didn't include soiling effects. So that's when particles actually settle on panels, and this may lead to an underestimation of the true impact. They're weed whacking outside my window. Is the sound really bad?
No, you're good.
Okay. Okay, and then some other insights from other research show that the technology use in panels matters. So crystalline silicone panels, especially monoside panels, appear to be more resilient to smoke than other panel types. However, this is an area where, again, more research is needed. And again, going into forecasting improvements, integrating aerosol data into aerosol-aware models could improve accuracy and reduce costly overestimations. And lastly, going into grid-level solutions, it's worth it to look into more storage and a diversified renewable mix to reduce variability from wildfire smoke. And lastly, new research is emerging on geospatial models that map real-time capacity reductions due to smoke, enabling better scheduling and grid planning. So basically the key takeaway I want everyone to take from my presentation is that better measurement of smoke means better preparedness. So looking into how we can expand smoke monitoring and integrating wildfire risk into energy planning will be key to sustaining solar performance in the future. So thanks for your time there. And then I just want to take a quick moment. I'm currently working on some unrelated research to wildfire smoke. And this is focusing specifically on the financing of community energy projects. And we're looking for survey respondents. So if you have experience financing community energy projects, we'd love for you to tell us about it by completing our survey. And we're going to be building a platform to share data on financing mechanisms, business models, and ownership structures. And yeah, I'll leave it there. Thanks for your time, everyone. I appreciate the opportunity to present.
All right, thanks everybody. So this is my opening slide, and I want to show one of Lytton's largest solar projects is on the K-12 school. And what happens is it was built in, I think it was 2020. I can double check on that. But the metrics that Sam spoke about are not being measured. Nobody's measuring the operational impacts of cloud or smoke. So that's part of that learning thing that what I really appreciate about Sam is they're saying, look, if I have a purple air quality monitor as well as my solar production, to be able to show that. I don't necessarily need to know that per se for what my needs are, but it is really cool. I know that I've seen solar production for a day when a cloud comes over and you're going like this and it drops down and the cloud patch drops back up. So I'd like to be able to see that correlation. So I just wanted to say this is Lytton First Nations' largest solar project. Next slide, please. So Akwant Low, Cookstay Bath Cookpi, Akwant Low Shnuka, Kanai Hens questions look at mo. So much like you give a land acknowledgement, I just said a few words in my language, basically saying, hi, my name is Patrick. Thanks, Fraser Basin Council, and hello, everybody. You'll know the link down here at the bottom is that these links should work when you get the deck. And next slide, please. There are basic common sense things, and you'll see it here. Does solar or does smoke impact solar? Absolutely. How about the fact is, guess what? What you do to land, you do to yourself. There's my grandparents on the left, and that's my grandmother and my mom when she was 10 in 1953 on the right. And one of the things they talked about is what you do to land, you do to yourself. And they also talked about this responsibility on Indigenous people to manage land and resources for future generations. And they have to have the same opportunity, if not more, than we have today. So an Indigenous perspective is that the needs of the future outweigh the needs of the now. But when you get contact, colony, confederation, and capitalism, that's called learned behavior. Next. So what's happening is when it comes to smoke and solar production, to me, it's a symptom of a bigger problem. I throw a picture of the Canadian flag, and I really appreciated how Sam's deck actually showed, the wind patterns and stuff like this. It's frightening. It's frightening to be in a cloud of smoke. There's health reasons, there's anxiety, there's eye things, there's occupation health and safety things, and now we start learning that our solar production diminishes. And when we look at something like Kanaka Bar's subdivision, we put in 100 kilowatts of installed solar to power all 12 buildings, but now we're finding out that we're not meeting our production targets. And nobody's tied it to smoke and or cloudy days and stuff like this. So something's happening. But if you look here, we intentionally only put in 100 kilowatts where we could actually see that a whole field to the south could be expansion. So if we're not hitting net zero and if we're not meeting our energy consumption on a daily or weekly or monthly basis, we can't expand our solar fields to accommodate for lack of production. Next. And so when I talk about a symptom of a bigger issue, I can't remember, I think Erin, thank you for that introduction. She left off the fact is I've done some work in renewable energy, but I've also been monitoring climate change for a really long time. So the other day I thought I'd pull out, I guess 2 days ago or yesterday, for those people, here's a link to a story. Lo and behold, we're in a new reality of climate change, all right? The warmer it gets, the more fire. So whatever Sam is researching, there's logic flow. It's not going to get better. It's going to get worse the more fires. So this is the cantilever fire in the picture here, and that huge plume of smoke. And yet it's the 5th fire of the year here at Lytton, right? Evacuation alerts, orders, losses, recovery, and rebuild. And as Sam spoke about, obviously I lost my home in my hometown on June 30th of 2021, and we were about maybe 15 to 20% rebuilt after 4 years. It's not easy being in recovery and response mode. And so I wouldn't wish that on anybody. So one of my things is if you make the investments in fire resistance and resiliency now, we can't eliminate the risks, but we can mitigate it. So for me, the solution to smoke and solar is more solar panels and bifacials, maybe white paint on your rooftop. Next. But the most important thing here is that when I talk about a symptom, is climate change real? I live at ground zero. My collective conscious memory goes back over 10,000 years. And I know everything that's been happening since 88 to today's date does not jive with what I know. The weather has changed, the seasons has changed, everything is changing. And how do I transition? How do I adapt? Right? So what we have here then is is that if we know that things are changing and we accept that it's going to occur in greater frequency, duration, and intensity, then maybe we can do something about it. So for Lytton, Kamchin there is Lytton's traditional name. In 2023, the community said, okay, look, here is our comprehensive community plan. They wanted climate change, transition, and adaptation to become a priority. In 2024, we did the preliminary assessments of available information and forecasting using a third party. Next. And then we got together, the youngest to the oldest, right? We sat down here and say, hey, climate change is real. What are our planning areas? We've come up with 12 planning areas, and we're just whiteboarding, things that we can do and how to do it and when to do it and costs and all this sort of stuff. So the idea behind it was is, don't sit down here. Ottawa's not going to give me a solution. Victoria's not going to give me a solution, and certainly not Alberta. The solution, if we're going to have a chance, we survive for 10,000 years of community, is ask the people who live here. What is the risk? What is the trend, right? Don't worry about the consequences. What are the solutions? And then work together in prioritizing programs and projects that underneath these planning areas, right? Roll out an implementation schedule and meet, let's say quarterly or annually, say, okay, this is what we've done over the last 3 months. This is what is yet to be coming. And, create this. Information is power to take on eco anxiety and solastalgia and people pissed off that they're frozen sockeye thought. You get them together and say, well, here are the solutions. How can we implement them? So we had this incredible event. And just before this one started, we're going over the results. I mean, the amount of information that came in from community engagement is a lot. So I've actually got a couple of people help me reconcile all of that information. Next. And so what Elephant is doing is working together as a community to come up with its climate resiliency plan, right? The infrastructure plan, the housing plan, and the design plan. So when you get the doc, you're going to read it. So why are we doing this? Remember, we need to give the tools, the foundations for our children and grandchildren. What we say or do today determines my grandchildren's future. So let's give them the tools. Let's make the investments today so that they have a chance. Next. Right? When I talk about future generations, so on the left is what I call a logic flow or a waterfall. Weather determines your water, food, and shelter availability. Weather is changing, therefore your water, food, and shelter is varying. I mean, we, for 10,000 years, we lived in holes in the ground, which are called pit houses with 4-foot earthen walls. There was zero chance of fire or damage to the house. Then the 4-foot earthen walls, there's zero chance of thermal penetration, which means the summer temperatures didn't come in and the winter temperatures didn't come in. If you wanted to, I've been there. So but point is, after contact, we started living in stick-built homes. We're starting experiencing this. So my sense of humor is, for those of you who don't know, Maslow's hierarchy of needs is coming from Maslow came up and spoke to the First Nations of, I think it was both Alberta and Saskatchewan in 1943 to come up with this hierarchy of needs based on Indigenous perspective. According to my wife and my kids and my grandchildren, no, there's similar things that Maslow wasn't aware of. So I just so you know, it's not just about creating physiological foundations. It's about, there's a few other things we need to factor in today. Next. So when it comes down to it, and I'm going to be mindful of the time here, is that for those of you who don't know, I believe that there are 5 project areas. And so whether it's biomass, and I'm not going to speak a lot about decommissioning. So while smoke will impact your solar production, what I'm telling you, wildfires will wreak havoc on your operations. So simple thing, quit building things that burn. So during your feasibility and design, permanent construction, don't build things that burn. Renovate and retrofit and protect your assets, built assets, wherever they may be, from wildfire. Right. And when Sam mentioned that there's actually a better quality solar panel that I'm going to be looking into that a little bit more. Obviously, I mean, solar advancements have over the last couple of years have been through the roof. We've seen, I remember installing my first 200 kilowatt solar panel for $750. And now we understand I can get like 500 kilowatts of solar for $200. I mean, it's like, I should have probably not bought beta. or VHS when Blu-ray was coming. But the point is, if you don't build your first solar project, how are you supposed to create that mentoring and capacity development and the information you need for the future? Future proofing is a concept that's not new. Basically, protecting your asset from the known weather, the risk, and right, we can't eliminate consequences, but we can mitigate them. If your asset survives the wildfire, it means you don't have to rebuild it. So this is critical. So remove the fuel when and where you can. I know down at Kanaka Bar, for example, they fenced it in and they mowed the lawn, and now they've released the goats. So goats are keeping the weeds down from getting into uh, the solar panels. But there's other different ways you can do here. And so at the end of the day is protect your asset from from the wildfire and the risks that are coming from extreme weather. And so it goes back down to invest now or pay more later. And when I say that here is that we want our power to be working regardless of the weather. And much as I love BC Hydro and I love how my governments are saying, we got your back, Jack, experiencing 3 days of 20+ hour power outage during a heat event is not fun. So we're highly motivated here in our region and our communities to start developing our own power from whether small scale wind, hydro, biomass, geothermal. We're not 100% sure, but when you're Canada's hotspot, I think solar works. Next. And again, when I talk about these little isms that are out there, we'll call them wisms. I said earlier, pay now or pay more later. You know what? Ounce of prevention leak is a pound of cure, right? Stitch in time saves 9. Protect your assets, and the hit that comes on solar from smoke and or cloud. I can't remember. There's a few other things. I never thought about the soiling thing, and it was really interesting because I remember before I lost my house in a fire, my wife came in and said, "Honey, cell number something has bird poop on it. Go up and clean it." So there's the amount of accuracy that can come from monitoring your solar production with the software that comes with solar is absolutely amazing. I encourage all of you to have a look at the nature of things. This is Sri Suzuki's version. We're going to be okay as human beings. Our challenge, though, is that the environment that surrounds us, that gives us life, doesn't have the ability of human beings to transition and adapt. So let's work together to share that information, and whatever that is, whether it's smoke, whether it's fireproof building materials, whether it's controlled environment agriculture, let's work together to make sure that as Canadians, we have choice, we have options, that we're aware of them. And, instead of relying on the federal and provincial governments or other people, give Canadians an opportunity to determine their future. So thank you very much. And by the way, that is my youngest daughter. That is Treacy, who was born in 2021, shortly after the fire. And in that tummy is Felix. Felix is the youngest Lytton First Nations band member, and he was in a picture with the oldest. Everything we do, we should be doing for our future generations. And I'm asking all of you, by all means, pursue the economic development side, pursue the capitalism side, but keep in mind that find your why. And my why is my children and grandchildren, and I wish you all the best. So thank you very much.